Okay, no, that's fine. You can sit. Okay, so, that's okay?
Yeah, no, yeah, right here.
He didn't lose it.
Oh, it's back.
So he will sit here. Oh, but Marcus doesn't.
Yeah,
We can fit it on a chair.
can we?
Yeah.
Why not?
Yeah.
Como el día. Last minute, it's a question. Will you be fine supporting a resolution to end the Korean War?
What?
Will you be fine supporting a resolution to end the Korean War? Que se exija la ONU. Está bien.
I know.
¿Está bien?
Yeah.
Okay.
Morning. How are you? Okay. Yes, consent. Sorry,
Matt. And back. Pretty good. How are you? Did you
Well, that's actually one. The other, oh, there's two there. There's two there. One right there.
It's a very simple tweet.
We could probably.
Yeah.
Their seat savings.
You might want to capitalize chairman, but I don't think that's a big deal.
No. Too much trouble.
Well, I would do it.
I know, it's
But
just
it's my
that
job.
I don't want to go back. We're a little late as it is. How long shall we wait here, you think?
Oh, what do you think? Are we ready to go? Or?
Yeah, as soon as we shut the door here with the last couple of people, we'll let them take their seats and then we can get going. All right, so then we got.
It's a great sound. The committee will come to order. Good morning and welcome to our first CJS hearing of the 116th Congress. And I want to take just a moment to clarify something. CJS stands for Commons Justice Science. This does not stand for Congressman Jose Serrano. I have no committee named after me. First, I would like to recognize and congratulate my friend and colleague, Mr. Adderhall of Alabama, who will serve as ranking member. I look forward to working with you in Congress as we make important decisions on what investments to make and continue our vital role in conducting oversight to ensure the executive branch is spending taxpayer dollars wisely and investing in our nation. I also want to welcome back returning members of the subcommittee, including our Vice Chairman, Mr. Cartwright of Pennsylvania,
Thank you.
Ms. Meng from my home state of New York. They'll be joining us in a little while. Ms. Roby of Alabama and Mr. Palazzo of Mississippi. Members joining us for the first time are Ms. Lawrence of Michigan, Mr. Chris of Florida, Mr. Case of Hawaii, Ms. Captor of Ohio, who in her spare time chairs the Energy and Water Subcommittee, and last but not least, Mr. Graves of Georgia. My colleague and ranking member of the Financial Services and General Government Subcommittee. Welcome, everyone. It's a privilege and honor to serve with you in this Congress, and I hope you find the work we do on this subcommittee as rewarding as I have. We will agree and disagree across many areas, but it remains incumbent upon all of us to get a final product out of subcommittee, full committee, and through both chambers of Congress that will make us proud. I remain committed to meeting the challenges ahead and doing that together. And I must say on a personal note that this has always been my favorite committee. I've served as ranking member here with Frank Wolf and with Harold Rogers. And so this is quite a day for me, but I have as much desire as my colleagues in the Republican side have to make sure that we get a bill out and get a bill passed through both houses. Now, I want to welcome Dr. Neil Jacobs, who serves as Assistant Secretary of Commerce for Environmental Observation and Prediction, and as of yesterday, NOAA's Acting Administrator. As of yesterday, right? And today? Not the acting. Okay. Congratulations. In this new role, Dr. Jacobs will oversee NOAA's $5.4 billion budget, which in addition to including NOAA's sea, air, land, and space observing platforms and the critical environmental data they provide, he will now also cover the wet side of NOAA and all of its work in fisheries and coastal management. Prior to joining NOAA, Dr. Jacobs served as Chief Atmospheric Scientist at Panasonic Avionics Corporation, was chair of the American Meteorological Society's Forecast Improvement Group, and served on the World Meteorological Organization's Aircraft-Based Observing System Expert Team. Next, I also want to welcome Dr. Michael Freilich, who has served as the director of NASA's Earth Science Division in the Science Mission Directorate at NASA headquarters since 2006. His creative retooling of the Earth Science Division's approach to research has been widely credited with protecting and enhancing the agency's vital work. Prior to his tenure at NASA, he spent most of his career as professor and as associate dean at Oregon State University's College of Oceanic and Atmospheric Science and member of the technical staff at the Jet Propulsion Laboratory in California. This statement is really a test on how well you can handle the English language, and being that English is the second language to me, I'm still dealing with it. Dr. Freilich, it is my understanding that you will soon be retiring from NASA. The agency has giant shoes to fill, given the many years you have dedicated to this field. Thank you for your service to the American people. We wish you well on this new and exciting chapter of your life. Both NOAA and NASA have critical missions. What they are observing, both above and below us, is affecting us in many ways. This hearing will help us learn from two leading experts about how climate is changing, how that will impact our country and economy in the short and long term, what research these agencies are conducting to help prepare us for the future, and how strategic investments from our subcommittee will help meet those challenges. Over the weekend, it was reported that the White House plans to name an ad hoc group of scientists with alleged ties to the fossil fuel industry to refute November's Interagency National Climate Assessment report that I have here. This unaccountable working group appears set deliberately cherry-pick data and science with the sole purpose of pushing back against a widely accepted science around climate change. This only serves to diminish the magnitude of this crisis, and it is dangerous. It also undermines the important climate research being conducted by devoted scientists at federal agencies like NOAA and NASA. As I have said many times, it is more than evident that our climate is changing and doing so very rapidly. The people of Puerto Rico saw this firsthand as they experienced the largest natural disaster in their history with Hurricane Maria. From the droughts fueling wildfires out west in California to hurricanes devastating the continental southeast year after year, our Earth is experiencing record temperatures that cause extreme weather, affect food supplies, and devastate local economies. The federal government must have the tools and resources it needs to study these changes so we can prepare and respond accordingly. The CJS Subcommittee leads the way in this effort. Gentlemen, it's a privilege to have you join us for this important discussion and to learn from your expertise on this subject from the perspective of the agencies you represent. And as I told Mr. Cobbleson, who was the former chair of this committee, if we can't agree that there's climate change, can we at least phrase it in this way? Something's going on, and we have to look at it. Before we begin, I'd like to recognize my friend and colleague and a person I'm looking forward to working with and trying to reach agreement as much as possible so we can do the work we have to do. Mr. Adderholt for his opening remarks.
Thank you, Mr. Chairman, and thanks for yielding. Let me first say congratulations to you on your new chairmanship. It is well-deserved and well-earned, and as most of you in this room know, Mr. Serrano is a very hard-working, well-respected member of the Appropriations Committee, and I'm honored to serve alongside him as ranking member. I'm thankful for his friendship and that we've maintained over the many years, and look forward to working together with him as well as on working in this subcommittee on Commerce, Justice, and Science. And it is my hope that as we enter this new Congress, we will continue to reach across the aisle and tackle those tough issues that our constituents face each and every day. Like the chairman, I'd also like to take a moment to welcome our witnesses to the subcommittee this morning, Dr. Neil Jacobs and Dr. Malik Freilich. Thank you for joining us today and your service to NOAA and to NASA both. And as the chairman mentioned, Dr. Jacobs, congratulations on being named as acting administrator at NOAA, and we look forward to working with you in that capacity. As we await the arrival of the FY 2020 budget request, I want to thank Chairman Serrano for holding this oversight hearing. It's important that the committee hold these types of hearings to gain a better understanding of the priorities and the work of the agencies that are under our jurisdiction. Today's hearing focuses on the topic that is important to all of us. Climate change is not a new issue or an idea. And here in Congress, we have debated the climate issue for many decades. Most of us agree that the climate is changing, and we want to be good stewards of the earth so that our children and our future generations can enjoy a healthy environment. But we often disagree about the major drivers of climate change, the best way to address it, and how to prepare for the future. As members of Congress, I believe that we should focus on fostering innovative ideas to address the changing climate. We should be exploring and investing in technologies that reduce pollutants and protect the long-term health of our planet, but do not impede energy development. After all, Congress should promote the all-of-the-above energy solutions policy. To succeed, the United States needs a broad portfolio of affordable energy technologies to create cleaner energy. A priority should be placed on putting forth realistic market-based solutions to further the United States' dominance of the clean energy market. Climate solutions need not compromise the American economy or put unnecessary stress on the American family. Research being done at NOAA and NASA is making significant contributions in the advancement of earth science and its applications, and it plays a critical role in informing our policy-making efforts. Therefore, when it comes to climate research, it is imperative that we focus our resources on advancing our space and ground observation and measurements to improve data accuracy, sustainability, and validity. This will allow us to speculate less, gain a better understanding of the complex relationship between Earth's changing climate and weather patterns, and formulate more concrete long-term climate models. Mr. Chairman, I hope today we can have a thoughtful dialogue about the observations, models, and scientific analysis that NOAA and NASA carry out to better understand this ever-changing planet we call Earth. NOAA and NASA's technological and scientific abilities apply to us as policymakers to understand climate trends, impacts, and risks so that we are equipped with the information to best prepared for our nation in the future. Mr. Chairman, thank you for letting me share my open remarks and again to welcome our witnesses that are here before us this morning, and I look forward to the testimonies and the discussions that lie ahead, and I yield back.
Thank you, Mr. Adderhold. Thank you, Dr. Jacobs. You are recognized at this time for your opening comments.
Good morning, Mr. Chairman and members of the committee. Thank you for this opportunity to testify at this hearing. NOAA plays an essential role in advancing scientific understanding of Earth's climate system through sustained observations, integrated modeling, and interdisciplinary research. Accurate observations of the current state of the environmental conditions are critical to building a robust and reliable time series of historical data that is required to enable more complete understanding of the complex processes that regulate Earth's climate. NOAA's observing system network extends throughout the oceans, measuring key metrics including temperature, currents, chemistry, and sea level. Terrestrial observations monitor precipitation, soil moisture, land use, vegetation, snow cover, glaciers, and sea ice, as well as many derived data sets from proxy data. NOAA samples the physical and chemical properties of the atmosphere through a wide range of systems, from in situ observations provided by weather balloons and aircraft and surface instrumentation to remotely sensed satellite data. High-quality, uninterrupted, long-term measurements of greenhouse gases, aerosols, water vapor, ozone, and ozone-depleting gases are essential. Quantifying the sources and sinks of each of these climate-forcing agents and characterizing the roles they play in the climate system are vital to advancing the state of knowledge in climate science. Throughout collaboration with our NASA colleagues, NOAA's Space Weather Prediction Center monitors total wavelength integrated energy from sunlight, which is referred to as the total solar radiance. To derive meaningful information on trends and interactions from these observations, they must be monitored for decades or longer. NOAA's climatological predictive capabilities span the medium range and subseasonal to seasonal and beyond. Our suite of prognostic tools can be divided into statistical and dynamical models. The monthly to seasonal forecasts come from the Climate Forecast System, or CFS, which is based on the Global Forecast System, as well as a North American multi-model ensemble, which is a suite of 7 different models. This forecast projects out 9 months, but research is being done to extend the longer range predictions out to 24 months. Prediction of climate variations ranging from El Nino and the Madden-Julian oscillation to sudden stratospheric warming events altering the polar vortex provide long-range probabilistic guidance on when future conditions will be favorable for extreme weather events that impact lives and property. From tornadoes and hurricanes to cold air outbreaks, heat waves, and flooding. The next generation CFS will be FV3-based atmospheric model that is two-way coupled to an ocean model with increasingly realistic representations of physical and chemical interactions. The new CFS will be a part of NOAA's transition to the Unified Forecast System, which spans large time scales and space scales with a common architecture. Decadal forecasts produced by NOAA's Geophysical Fluid Dynamics Laboratory are used in long-range projections. The verification of these models is made using historical analyses and reforecasts. In order to extract a meaningful signal, a large ensemble of models and substantial high-performance computing resources are required. In addition to the suite of dynamical models, NOAA runs several statistical models. These statistical models include canonical correlation analogs, regressions from post-processed dynamical model output. These value assets not just as predictive tools, but also a means to refine and improve the dynamical models. In an effort to improve transparency, NOAA makes all of its data, from raw observations to post-processed model output, available to the public via archives preserved at NOAA's National Centers for Environmental Information. In addition to the data, the source code is used to process the data is also made available. However, much of this existing code lacks sufficient documentation and support. This makes experiment replication and software change justification challenging for those outside the climate science field. With limited resources, we believe it is best to focus investment on developing more accurate and reliable models. Substantial progress has been made over the last several decades in observations, modeling, and understanding, but the mission remains incomplete. Key scientific uncertainties limit scientists' ability to understand and forecast changes in the climate system. Factors responsible for climate forcing and those underlying climate variability need to be better characterized and quantified to improve the nation's ability to predict the future state of the climate system, including the occurrence of extreme events, with more accuracy than today. Mr. Chairman, Ranking Member Adderholt, and members of the subcommittee, thank you again for inviting me here to testify. I'd be pleased to answer any questions you may have about NOAA's climate programs.
Thank you, Dr. Jacobs. Dr. Freilich, you're recognized now.
Chairman Serrano, Ranking Member Adderholt, members, thank you for the opportunity to discuss NASA's roles and contributions to understanding our planet, including climate research. The changing climate has profound impacts and opportunities for us and for our adversaries. Global average sea level is rising, impacting our nation's coastal infrastructure and the more than 100 million people worldwide who today live within a meter of sea level. Our satellite measurements show us not only how much, but why sea level is changing. Average surface temperatures are rising. Since 2000, we've seen 18 of the 19 warmest years ever measured. Rising temperatures impact agriculture, transportation, disease vectors, and ecosystems everywhere. Arctic sea ice is decreasing and thinning, and the Greenland and Antarctic ice sheets are evolving. NOAA and NASA measurements suggest that extreme weather events are becoming more frequent and intense. Now, NASA measures and monitors these changes from space. Then we use the measurements and our research programs to understand the natural processes that define our environment. The changing climate also presents us with profound responsibilities. Only humans can alter our present actions based on what we think the world will be like generations in the future. But NASA does not make policy decisions. Rather, we take the measurements and conduct the research. NASA makes the facts and the understanding available to you, decision makers, to help inform your decisions and to monitor whether policies that you decide upon are having their intended effect. Now, the fact that we know with certainty that the climate is changing is actually a profound testament to our nation's technological and scientific abilities. NASA's and NOAA's satellites monitor most of the Earth's natural processes. Climate-scale trends have all been detected from space. Our applied sciences activities transform the measurements and the understanding into information products that improve lives. Now, NASA has 22 Earth-observing research satellite missions on orbit, and 14 more are in development for launch before fiscal 2023. Just this past year, in 2018, we launched 5 major Earth missions and instruments, and our next launch will be the Orbiting Carbon Observatory 3 to the International Space Station in late April. Most of our missions involve international and interagency collaboration. We collaborate with the U.S. Geological Survey on Landsat, and we develop instruments and satellites jointly with NOAA. We also work with NOAA, the Navy, and the Air Force to transition research products into operational environmental predictions. Our Earth science budget supports high-end computing for all of NASA, programs for early career scientists, and importantly, the development of Earth system models, including global climate models. In the applied sciences, the NASA U.S. Agency for International Development program called SERVIR improves environmental understanding and decision-making capacity in developing nations. We help our nation and our international partners respond to natural disasters. In fiscal 2018, our Disasters Applications Program supported U.S. and international response to earthquakes and tsunamis, the California wildfires, floods and landslides around the world, volcanic eruptions, and hurricanes and typhoons. We innovate. NASA invests in technology developments, and we're demonstrating many of those new technologies on CubeSat, little satellite missions. We put Earth-observing instruments on the International Space Station, and we're flying satellite constellations to demonstrate the observing systems of the future. We're building instruments, NASA research instruments, to fly as hosted payloads on commercial satellites in geostationary and low Earth orbit, partnering with the private sector to fly on their satellites. And we have contracts with 3 private new space companies to purchase their Earth-observing data from small satellite constellations. After evaluations, we plan to pursue long-term data buy contracts benefiting both the government and the private sector. And NASA-funded research results and NASA personnel were foundational contributors to the 4th National Climate Assessment. So while the largest uncertainties in predicting the long-term future climate result from our lack of knowledge of future human decisions, the satellite observations help us to advance Earth system science and enable better resource management and decision-making. Only from space can we measure all of the important quantities, link all of the space and time scales, and understand our complex planet in order to help improve lives. Thank you again for this opportunity to discuss NASA's activities to observe and understand the Earth, and I too would be pleased to respond to questions.
Thank you. Despite the White House's recent call for a new panel to review the science around climate change, the National Climate Assessment, along with the Intergovernmental Panel on Climate Change's recent report, these are the foremost documents explaining the changing climate and its impacts on the planet and society. For both witnesses, and if you could please just give me a yes or no answer to this, would you agree with that assessment?
Well, my agency was one of the 13 agencies that signed off on it, so based on the assumptions that they made on the RCP projections, yes.
And for the same reasons, NASA also signed off on it and was a foundational contributor, yes.
Thank you. Now I would like to walk through some of the top-level findings of the National Climate Assessment from the first 2 paragraphs of Chapter 1. It begins, Earth's climate is now changing faster than at any point in the history of modern civilization, primarily as a result of human activities. Would you agree or disagree with this statement?
Certainly, if you remove natural variation like ENSO and PDO, then the remaining trend is anthropogenic.
Yes.
Continue from the report, and I quote, the impacts of global climate change are already being felt in the United States and are projected to intensify in the future. Would you agree or disagree with that statement? Jacobs.
There are all 4 scenarios, 2 of which were included in NCA 4, trend upwards, so yes.
Yes.
Further, the severity of future impacts will depend largely on actions taken to reduce greenhouse gas emissions and to adapt to the changes that will occur. Would you agree or disagree with that statement from the report?
It depends on which pathway you actually look at. The severity of 8.5 is obviously more severe than the other three, but certainly it's an undisputed fact that humans are producing the CO2. What is not discussed in there is the removal of carbon sinks like vegetation. So you can also increase the levels of CO2 by removing the sinks.
Thank you. So you're saying that there is human cause, but there are other causes too, as you believe?
That's correct. And in most cases, humans are removing the sinks as well.
And your answers?
Basically, yes. On the time scale of the next couple of centuries, what we do in terms of putting fossil fuel carbon into the atmosphere and removing and constraining carbon levels in the atmosphere will be the most important thing for defining our climate.
Thank you. Now skipping down to the second paragraph of the report, climate-related risks will continue to grow without additional action. Would you agree or disagree with that statement?
NOAA's role in that report was just providing transparent and defendable information as far as the atmospheric measurements, so that's beyond the scope of our agency.
So that's a yes or a no?
That's not what our agency's in charge of.
Yes, sir.
Similar answer from NASA. It's our job at NASA to make the measurements, to provide the understanding based on our research, and then to make that information available to you, the policymakers, to inform and guide your policy decisions.
Decisions made today determine risk exposure for current and future generations and will either broaden or limit options to reduce the negative consequences of climate change. That's another part of the report. Would you agree with that? Yes or no?
Well, the report actually discusses that it doesn't evaluate the feasibility or socioeconomic assumptions within the RCP, so that's also probably beyond the scope of our agency.
Doctor?
Decisions made today will influence the evolution of our climate, yes.
Thank you. Finally, and I quote, while Americans are responding in ways that can bolster resilience and improve livelihoods, neither global efforts to mitigate the causes of climate change nor regional efforts to adapt to the impacts currently approach the scales needed to avoid substantial damage to the U.S. economy, environment, and human health and well-being over the coming decades. Would you agree on that statement, with that statement, yes or no?
If the policymakers decide to address this, it certainly needs to be done on a global scale, not a regional scale.
And again, that is quite policy dependent. What we can do at NASA and in NOAA is based on our measurements and our understanding and our models. We can present to you the regional and global impacts of, potential impacts of policies that you may be considering.
Thank you for indulging me, gentlemen, with that, but I felt it was important to get all of that on the record. According to the U.S. government's best scientists, we're not doing nearly enough to avoid substantial damage to our economy and human health from the impacts of climate change. I thank you both for your answers. And Saddle?
Thank you, Mr. Chairman. There is a tendency among the general public in the climate debate to cite shorter scale weather events as evidence for and against climate change. In your testimonies, you said that thanks to satellite measurements and scientific analysis, you're increasingly able to detect climate threats and separate them from the environmental variability we know as weather. Can you give us an example of a recent extreme weather event or variability that, while not inconsistent with the trends you associate with climate threats, you nevertheless would distinguish as separate from what you would consider evidence of climate change?
So
Go ahead.
I'll take
yeah,
that.
Mr. Friday. That's Friday.
So The intent of the quote that you read was to say that we are able to understand the underlying trends in the midst of a lot of instantaneous variability, if you will, in the quantities that we're measuring. The short-term variability is what we call weather, and the longer-term variability and trends are related more to climate. Now, what we have both said in our testimonies is that the changing climate is changing the statistics, the frequency and the intensity of weather events. So to say that a particular weather event, and studies have been done at the national academies on this, is, quote, the result of climate changing is not exactly precise. But to look at the sum total of weather events, where they're happening, extreme events, where they're happening, their magnitudes and their frequency, those statistics are being impacted by climate.
So to add to what Dr. Freilich just said, there's two other things. So I would separate short-term natural climate variability from long-term trends. So for example, we have an El Nino signal. In 1998, there was a very strong El Nino that produced extremely high temperatures. So a lot of and that's still something that we would call climate, more climate than weather. And then there's instances where you're actually looking at hurricane intensity and frequency of those. And a lot of those studies are actually done by using climate projections. So a future projection of what the sea surface temperature water will be like 100 years from now, and then running hurricane simulations with those projected conditions. So the findings based on those studies, some of them show increased frequency, some show decreased frequency, most show increased intensity, but they're predictions based on predictions. So the underlying assumption is that one of those particular emission scenarios will actually materialize.
What is, would you say is more difficult for scientists to predict, climate trends over the next 50 years or weather over the next 50 years?
Well, the skill of our weather forecast models is really limited to probably 2 weeks or less. But I would imagine that the evolution of the forecast skill in the weather model is improving quite rapidly. That's something that is an initiative of mine that we're working on right now. The trends in climate rely on a much more complex feedbacks and interactions. And so actually, predicting changes in climate is far more complicated than predicting changes in weather.
I would agree with Dr. Jacobs on most of that. Again, the ultimate sort of 50 to 100 year evolution of our climate depends in not insignificant amounts on the policy decisions that you will be making. And those are not built into our climate predictions. Earth is a very complex system. We have Earth system models, but as Dr. Jacobs said, they are all based on particular assumptions about what humans will do, as well as knowledge that we've generated on the Earth's natural processes and their interactions. That makes it a very complex prediction system, as Neil said.
So between the two, would you agree that climate is more difficult?
I think so.
Yep. Okay. All right.
But you phrased the question as predicting weather 50 years from
Yeah.
now, and I think that's probably, Noah would agree that that's probably beyond our capabilities.
Yeah, I interpreted that to mean weather prediction 50 years from now. Skill, not a 50-year weather prediction.
Right, yeah. Exactly. That would be a little bit more difficult. I yield back.
Thank you. Everyone, we will rotate from one side to the other, and speakers will be based on where you were when the gavel went down in seniority, but who was here at that time. So with that in mind, and no matter how I try to explain it, Mr. Cartwright is next.
I'm going to take that as a compliment,
It
Mr.
is a
Chairman.
compliment.
Thank you. Dr. Freilich, Dr. Jacobs, thank you for being here today. I want to talk about support for the scientific validity of the National Climate Assessment first. Dr. Jacobs, in describing NOAA's rule, you have said, we've got a job to produce the most accurate, robust, and defendable science. Policymakers need to be able to trust the science. Have I quoted you correctly? So are you and your staff faithfully fulfilling this responsibility?
Yes.
And did NOAA sign off on the National Climate Assessment? I think you already said so. In Chapter 13 of the NCA, it says, quote, there is robust evidence from models and observations that climate change is worsening ozone pollution. This poses a significant challenge for air quality management. And are those claims backed up by robust and defendable science?
Everything in there is based on peer-reviewed literature.
And in Chapter 14 of the NCA, it says the quote, the health and well-being of Americans are already affected by climate change, unquote, and that health will further deteriorate if climate change continues. And again, are those claims backed up by robust and defendable science?
That's beyond the scope of NOAA's jurisdiction.
From Chapter 16 of the National Climate Assessment, I read, quote, climate-related disasters in developing countries not only have significant local and regional socioeconomic impacts, but also set back U.S. investments, humanitarian assistance, and national security. Is that claim backed up by robust and defendable science?
Well, we monitor the storms, but not necessarily the socioeconomic impacts.
I'll go to you, Dr. Freilich. Is that claim backed up by robust and defendable science?
Again, the science on impact is extraordinarily complex, but the measurements of inputs and enforcing is strong and robust and transparent.
Okay. And Dr. Freilich, when looking at the NCA, would you say that the projected climate change in the NCA is based on scientific and peer-reviewed data?
Absolutely.
And does the NCA represent our foremost experts, including yours and Dr. Jacobs's most accurate estimates of our climate future?
The NCA is a comprehensive, scientifically rigorous analysis and assessment of the available information primarily from the U.S. government, yes.
And in fact, in your written testimony, I noted that you both bolded and italicized the words, quote, know with certainty, unquote. Did I pick that up correctly?
You did.
And that was when you described climate change. Recently, White House Press Secretary Sarah Sanders described the NCA as, quote, the most extreme version and it's not based on facts, unquote. So Dr. Freilich, do you know who's advising Sarah Sanders on climate change?
I do not. NASA and NOAA is involved in the U.S. Global Change Research Program, that 13-agency program. We collaborate across the federal government and provide help to provide assessments such as the NCA.
I don't mean to interrupt, but I only have 5 minutes.
Sorry.
Did she check with you before making that statement?
No.
You, Dr. Jacobs?
So,
Did she check with you before making that statement?
no,
Okay.
The RCP 8.5 was the most extreme scenario, but the NCA 4 also used 4.5, which is a more medium-range scenario, but the impacts attributed to each weren't specifically broken out.
Is Ms. Sanders' description an accurate representation of the NCA? Dr. Freilich?
Well, as you saw, as I was talking perhaps, we have made measurements of many of climate indicators and many aspects of the Earth system, and it is clear that the climate is changing from our long history of measurements and our transparent and open analyses that are available to everyone.
To say that it's not based on facts, is that an accurate representation by Sarah Sanders?
What we present are based on measurements and open analyses.
And both NASA and NOAA signed off on the NCA report. Am I correct in that?
Correct.
All right. My 5 minutes are up. I yield back, Mr. Chairman.
Thank you. Mr. Palazzo.
Thank you, Mr. Chairman. And Dr. Freilich, thank you for being here today. I want to congratulate you on your pending retirement. So thank you for everything that you've done for NASA. Your work hasn't gone unnoticed. Dr. Jacobs, I also want to thank you for being here today. NOAA is a global leader in climate research, observing all the world's oceans and major seas. I'm proud to represent the Mississippi Gulf Coast, which is home to NOAA's National Data Buoy Center. For my colleagues that don't know, the center records crucial ocean data. From hurricane alerts to safeguarding our wildlife, Southern Mississippi knows the value of accurate and timely climate research. So Dr. Jacobs, can you speak to the important contributions that the National Data Buoy Center makes to NOAA's research?
So the buoy data is extremely critical in both weather and climate forecasting, because collecting surface observations, in situ surface observations, not space-based observations over the ocean, is extremely complicated because you have to physically be there. Surface pressure obs are one of the most impactful observation that we put in the weather models. And these are also observations that we use to cross-check with sea surface temperature that we derive from satellite imagery.
Dr. Jacobs, also in your testimony, you mentioned that implementing the Earth Prediction Innovation Center, EPIC, is among NOAA's highest priorities. You state that it will directly benefit taxpayers. Can you elaborate on what the program is and why it's so important?
Sure. So this particular center accelerates research to operations, and we're streamlining our modeling suite by combining our weather models with the same dynamic core as our climate models, and packaging the software in a way that can be run by the community. So various universities, academic institutions can download and run and help develop and advance this software. What we're also doing is porting this code over to cloud-based architecture, which addresses another problem which we have, is limited high-performance computing resources. If we're able to actually scale the research across cloud, we don't have a situation where our researchers are constrained to finite resources, so they have to execute experiments in series. Now they can scale their experiments and execute them in parallel, which accelerates the research process.
Dr. Freilich, this question is for you. You noted in your testimony that not all impacts of the changing climate are near-term negative, such as lengthened growing seasons, but you caution that these changes may disproportionately benefit nations other than the U.S., and my state of Mississippi is heavily dependent on agriculture. So on what or whose economic analysis is this suggestion based? And can you explain how growing seasons have changed here in the U.S. and what regions of the country, in your opinion, will be most impacted?
Certainly. Before I answer that, let me just give one additional testimonial to the National Data Buoy Center and NDBO. Personally, in my research and with NASA, we have used critically National Data Buoy Center measurements both to improve the accuracy of satellite measurements of winds over the ocean and to validate and thereby decrease uncertainty in those satellite measurements. So they really play a critical role, as Dr. Jacobs said. To go back to your main question, Perhaps the most recent comprehensive analysis was published in mid-September in the journal, prestigious journal Nature Climate Change, where they actually did a country-by-country wide analysis of a number of different scenarios of changing climate. And what they found was that based on various metrics, which are not all that important, except that they are incredibly robust, they found that India, China, the US, and Saudi Arabia, surprisingly, were the countries that were most vulnerable overall economically to the changing climate, and that in a negative way, and that Northern Europe, Canada, and the former Soviet Union were most benefiting from the changing climate, primarily in those cases because global temperatures or temperatures in those regions are lower than economically optimal now, but in a warming climate trend, the temperatures would increase and therefore their economies would become more optimal. In the United States, the National Climate Assessment looked at the impact of warming temperatures, among other things, and found that, in particular in the Midwest, that was probably the most vulnerable area from an agriculture standpoint to increasing temperatures, and that indeed the climate assessment pointed out that if things continue on the trends that they're on now, that our national agricultural production might be reduced for climatic reasons to sort of mid-1980s levels, unless there were technological improvements in both agriculture and the climate trend.
Well, thank you, gentlemen. I yield back.
Thank you, Mr. Chairman and Mr. Ranking Member, for today's hearing, and thank you to the committee staff for all the preparation that went into today's discussion. I also want to thank both of our witnesses, Dr. Jacobs and Dr. Freilich, for being here today, and thank you for your commitment to our nation. And I too want to congratulate Dr. Freilich for your upcoming retirement. Climate change affects our environment, our public health, and our national security. Each year, more extreme weather incidents affect our nation, causing tragic loss of life and economic damage. I represent parts of Queens, New York, and it's imperative for our district that we have a clear research-based assessment about the effects of climate change. My first question is about clean drinking water. In New York City, we draw almost all of our drinking water from the Catskill and Delaware watersheds. How concerned should we be in this country about our freshwater resources?
Well, I would certainly be concerned about it. Water is an essential natural resource. Along those lines, something that NOAA is doing is experimenting with aquaculture, and one of the things that we found out through some of the aquaculture of various oysters is that they actually provide a tremendous amount of water filtering capacity.
Are threats like aquifer salination in Florida, melting snow in the Rockies, or changes in precipitation and evaporation rates for standing bodies of fresh water something that Congress should consider and work on?
All of those processes that you talked about are indeed important, and indeed they are all measurable not only in situ, but from space. One of our NASA missions, GRACE and now GRACE Follow-On, makes precise measurements of gravity which can be related to actual changes in aquifer levels. And so we can indeed monitor how the aquifer levels are changing relative to the natural processes to determine the impacts of human activity.
Well, I'd like to take this opportunity to thank you for the support on the NIDIS reauthorization. So a lot of this is built into that, as well as the national water model system. So not only is it something, as Dr. Freilich stated, that we can observe, we can also predict it. So the snow melt, the runoff, that's a lot of things that NOAA's actually running computer models on right now to forecast. And we're in the process of coupling our atmospheric models to our hydrology models, because, of course, you have to know exactly what the forecast is for the rain in order to understand where the runoff and snowpack will be.
Thank you. My other question, Dr. Freilich, prior to joining NASA, you were a professor and associate dean in the College of Oceanic and Atmospheric Sciences at Oregon State University. Given both your testimony today, understanding our changing climate and research will continue to be very important to our nation's economy, well-being, and security. What more can Congress do to support STEM education to ensure that our nation's producing the best scientists in the world? And in the interest of time, if I could ask my second part too. And do you know of any potential gaps in STEM education that will affect our ability to track and understanding climate change? So what more can Congress do, but also our schools and even private corporations?
So I was going to address the impact of STEM, not just at the higher levels of education, but throughout our system. STEM education, the scientific and logical approach to identifying and analyzing issues, is vitally important for our national strength as an overall society. My personal experience, of course, has been at the upper levels of the education area. However, our daughter is a middle school biology teacher, and I can't emphasize enough how much support for rigorous STEM curriculum throughout the entire education system is vital to our nation for both male and female students.
One of the things that's extremely important for what we're doing for not just climate modeling, but weather modeling, is finding really qualified software engineers. And there's a major shortage in the government labs of software engineers for two reasons. The primary reason is we can't compete with industry, whether it's the video game industry or the comms industry, as far as recruiting and benefits and salary. The other issue is a lot of these universities are teaching software languages that are different than what we use in our computer models. And the industry is rapidly evolving in a different direction than a lot of the code that we use.
Thank you. You're back.
Thank you. Mr. Jacobs, I'm from Michigan, and we just had the Michigan State game. Where do you sit when there is a South Carolina and North Carolina game?
Oh, that's so I would have to say I'm an ACC person.
Oh, okay.
My wife went to Duke as well as NC State.
Okay,
so.
let's get to work here. President Trump has proposed deep cuts to NOAA's Great Lakes Environmental Research Laboratory in his previous budgets. As you know, I'm from Michigan, with the third largest source of fresh water in the world. Can you tell us about the work of that lab and why it's important for the nation to continue funding that program?
Well, on the budget cuts, we had to make some difficult decisions because the administration prioritized rebuilding the military and making investments in national security. So there were reductions primarily to external funding, and we continued to fund the missions that were critical, that were within the core mission of NOAA. The research budget within OAR on the climate side was $98 million, oceans was $93, and weather was $91. So despite the proposed cuts, climate was still funded more than weather. The labs themselves are instrumental in doing model development work and forecasting, particularly on things like harmful algal blooms, and integrating a lot of the biological and ecological models with the hydrological and atmospheric models.
So would you say it's important for the nation to continue funding this program? Because as was stated by my colleague, fresh water and drinking water is becoming almost an emergency level. We must have safe, clean, and affordable drinking water to live. And I'm very concerned when you start talking about reducing that funding. When we talk about national security, water is going to be a critical issue in America.
All of these programs are extremely important. It's just, and we're in a situation where we had to make some difficult decisions.
I think difficult, and the fact that we want Americans to live with safe drinking water is a critical issue. I want to ask this question to both of you. NASA and NOAA provide us with so much global observation data already, but where are there still gaps? What critical satellite data is still needed to refine our ability to track climate change? One of the challenges we have is with data, and I will say this on the record, this administration doesn't seem to grasp how important the data and the environment will play on us to be able to respond to the needs that we must. And so can I get some comments from both of you about this?
So the satellite data is extremely important, but I don't want to lose sight of the importance of the in situ data. So on the satellite data, the values that we collect are essential, but the vertical resolution is probably the weakness. But as critical, if not more critical, is the ability to calibrate the satellites. And to do that, we actually need in situ observations to calibrate the satellite instruments with. And this goes for not just temperature and water vapor, but also aerosols and gases. So right now we do have a program where we collect various gases with research instruments put on commercial airlines, and then we use these gases to analyze and calibrate the satellite information. But this program, even though I would consider it not nearly as expensive as actually launching and deploying a satellite, without the ability to calibrate it, the data that we get is really limited.
Thank you. Mr. Froelich?
Yeah, I agree with Dr. Jacobs. I'll focus on three areas of measurements that are particularly amenable to advancement from space. The first one is, as Neil said, atmospheric composition. We have the nascent ability, and we are constantly improving it, to measure the composition and changes of greenhouse gases in the atmosphere. This is essential for running climate models. It's also essential for you to see the efficacy of policy decisions that you might be making locally in the global scale. A second is vertical winds. This is at the very edge of our abilities right now. It addresses what a portion of what Dr. Jacobs said about vertical knowledge and measurements in the atmosphere, and it will improve our models immensely if we can do it everywhere and accurately, and it will help NOAA's forecasting of the weather and the environment on all scales. The third place that I would personally highlight is soil moisture. Soil moisture.
Okay.
The ability to globally understand, make measurements of agricultural conditions, if you will, both informs locally our farmers and also provide some stability in terms of food security, understanding how crops in other areas might be impacting prices at home.
Thank you so much. I yield back.
Thank you, Mr. Chairman. Welcome, gentlemen, and thank you for your expertise and for the years you're giving to our country. I hail from Ohio and represent the southernmost of the Great Lakes, Lake Erie, where we have had major challenges to our water system at the city of Toledo and other smaller water systems, so we've experienced firsthand what is happening with climate change. I also represent Brook Park, NASA, named in honor of John Glenn Lewis Labs at Brook Park, and we're very interested in your earth science work relative to, as Congresswoman Lawrence talked about, the Great Lakes region. I'm particularly interested in the NASA HAB, harmful algal bloom monitoring and modeling, and the underlying need for us to spread our wings a little bit and work with universities in the region that are collecting data. There's all kinds of data, but it's not necessarily organized in a way that helps us target resources effectively. And so my question really is, how are you working with all of the data sets that are being generated in the Great Lakes region, particularly Lake Erie, which is the shallowest and most drawn upon of the Great Lakes? It's really the canary in the coal mine for what's happening in the Great Lakes region. How can NASA exert more of a lead? So I loved your visuals, Dr. Freilich, and actually want to see if you have any others that are specifically focused on the Great Lakes in terms of what Congresswoman Meng talked about and the STEM education programs. We have a Great Lakes Science Center in Cleveland, which I represent, and also at Toledo Imagination Station. And we can have an enormous impact on the next generation if we can share your data in an understandable way from NOAA, from NASA, and draw our young people into the reality of what's happening, targeted even right down to their region. So my question is, how are you, could you elaborate on your NASA harmful algal bloom monitoring program and the modeling that you're doing in collaboration with others in the region? And just FYI, I represent the largest watershed in the Great Lakes, and if we don't get it right there, we're not going to get it right anywhere.
Absolutely. And we have a rather extensive harmful algal bloom program. We are in the process of developing the technology and the understanding to be able to predict the occurrences both in inland waters and in coastal waters of harmful algal blooms, and to track the blooms when they occur. This from space. Now, with respect to, you mentioned the Toledo
Yes.
Issue of several years ago.
2014.
When that giant harmful algal bloom took place, we actually funded and conducted aircraft flights
Yes.
with aircraft instruments out of Glenn to monitor and track that bloom. Subsequent to that, some Glenn investigators put in a competitive, highly competitive proposal. It was one of only 9 out of 43 proposals that were accepted to continue aircraft flights over several years, and they're even continuing now to monitor and track water quality and algal blooms in the area. One of the key elements of their proposal was the fact that they had brought together, just as you said, many different local institutions to pool the information and the understanding from the different groups in order to advance our knowledge of harmful algal blooms and their impacts.
Please let me know what more we can do there, because we live that crisis. And we're actually now not sure in terms of human health. We're looking at apparently higher rates of Parkinson's and Lou Gehrig's disease. And we don't know the impact on human health of microcystin and some of the cyanobacteria that's in the algal blooms. And it seems like science has got to run faster to catch up with what we're dealing with. Also, in terms of agriculture, you mentioned agriculture. We're not sure whether the soil itself, because we have higher rainfall, whether some of that is growing in the soil, and NASA doesn't have the ability to penetrate with satellite imaging yet what's in the soil. It would be nice to be able to give to our local weather reporters, hey, that sub-watershed is really sick right now. We don't have the ability to do that, and unfortunately, I'm just putting this on the record, we have the most tiled region in America. The old black swamp, it extends over Indiana. I think Secretary Pence is aware of this, or Vice President Pence is aware of this. Michigan, Western Ontario, and in Canada, and Ohio, obviously. But it is a giant soybean corn bowl and animal bowl, and we have more animals, 10 times more animals than people. And it's very, very difficult to figure out why Lake Erie's getting sick. We sort of know why, but we don't know from where, when. And so, and the water intakes are too high in the water in some of our cities. And EPA doesn't provide any money, really, for them to rebuild their water systems. So we've got this really critical moment, and it seems like the federal government is tiptoeing. If you can have any influence inside the administration, we really need a strike force for Lake Erie. That's what we need, and for this most troubled watershed. So if you can make recommendations to the record on that, I would greatly appreciate it. Thank you, Mr. Chairman.
Well, this Chris just came in, so, hi. We'll go ahead and let you begin our things that are, Chris, if you're ready, we're ready.
Good morning. Sorry I'm late. I double booked today, but it's great to be with you, and I appreciate the opportunities. Thank you very much, Mr. Chairman. And I want to thank our witnesses for being here. Appreciate your presence. I am grateful this subcommittee has chosen climate change as its first point of discussion, Mr. Chairman, for the 116th Congress. This is a topic that is near and dear to my heart, and one that is incredibly relevant to my district in Florida. I represent Pinellas County, Florida. It's on the West Coast, includes the cities of St. Petersburg and Clearwater. Sea level rise, nuisance flooding, saltwater intrusion, worsening weather. These impacts are real. They're happening now, and my constituents see it every single day. According to a recent analysis published in Science Journal, oceans are warming up to 40% faster than previously thought. Both witnesses, I'm curious, what does this accelerated warming mean for our oceans and for our weather? Either of you.
Okay, well, thank you very much. The vast majority, more than 90% of the excess heat that's being put into the Earth system is actually being trapped in the, is being manifested in the ocean. There's obviously a lot of focus on surface temperatures, but the heat itself is in the ocean. It has tremendous potential for rapid and otherwise changing environment and climate change should that subsurface heat, which was discussed in the science article, make it to the surface and then to the atmosphere. We are able to make measurements both in situ and from space to give us a more complete three-dimensional, two horizontals and vertical, picture of the heat distribution throughout the oceans right now. That is where technology and models have come together in both NOAA and NASA to give us a more complete view of the environment and how it might change in the future.
I would also like to highlight NOAA's Argo observing system, which are these profilers that go up and down in the water column and collect information. It's not easy to actually observe the oceans below the surface. We can do the surface relatively simple and straightforward with satellites. I mean, relatively.
Relatively.
Simple and straightforward.
But the Argo system is incredibly valuable because if we're going to run coupled climate models where we have an atmosphere coupled to an ocean model, the ocean model is going to need in situ observations and data assimilation. And so for both the initialization perspective as well as the model verification perspective, these observing systems are critical.
Thank you. And can you address what the human and economic consequences of this are?
That would really go beyond the scope of NOAA's mission. Our mission is just to make sure that the policymakers have the most accurate projections that we can produce.
I'll go a bit farther, but still focusing on the physical manifestations of this. And the Earth's environment is basically defined by two great fluid systems, the atmosphere and the ocean. They couple over 70% of the Earth's surface. And understanding the internal dynamics and the exchanges between the two defines our environment and then results in human and economic impacts. One of the graphics that we showed actually was sea level rise, and you talked about that. We are making incredibly precise measurements of global and regional sea level rise, and we understand why, because the satellites are telling us that half to two-thirds of the sea level rise is coming from putting more water into the ocean by melting glaciers and ice sheets, but the other portion is coming from expansion of the water that's in the ocean. As the ocean warms, it expands, just like the fluid in your thermometer, and that causes sea level rise too. From a human standpoint, it's just higher. We can not only see what's happening, but we can see why it's happening.
Does that mean I have to stop? I yield back.
Dr. Freilich, could you please contribute if you have examples of how you are providing useful climate-related information based on your measurements to technical and non-technical decision makers?
One example of this is through our applications program, which is designed specifically to take the measurements and the understanding that we get from satellites and research and make focused information products that address the questions of non-technical users, such as, what are the statistics of surface wind velocities? What will the statistics of surface temperatures be? How will precipitation change into the future? These impact particularly people like architects and infrastructure designers who have to make decisions today about what the conditions are going to be 50 years from now when their buildings and infrastructure are still standing. We provide the measurements from today and the model estimates into the future in ways that can be accessed by, as I say, non-satellite weenies, that is, non-technical people, specifically through our applied sciences program.
Do you find any of the same discussion that takes place in general, certainly in Congress, about those who believe there's a problem, those who believe that the problem is not to you? When this information goes out, are there people who reject it and say, that's not what I'm looking for, or I don't need that information, or it's not convincing enough?
The people on the ground need the information. Designers have got to, architects have got to design buildings, et cetera. So it's not a question of not needing the information. What we strive hard to do is to understand the specific information that is needed. And it's often very difficult for the user to articulate what he or she is looking for in terms of environmental information. And that's the role that our applied sciences program plays. It's sort of a flexible bridge between the non-technical users on the end and what we know and what we can provide on the other end. The key is to provide information in an accessible and efficient way to the non-technical user, not to present, a course in environmental science for them. And that's what we try to do in our applied sciences program.
Thank you. Either one or both. Puerto Rico has been devastated by recent hurricanes, and the federal government, in partnership with the local government, are investing heavily in ecosystem restoration and repairing infrastructure. How are you educating the public and local officials about the increasing systemic risks to the island? Could you explain what specific impacts are expected there? Either one or both?
I can touch on that from two different aspects. One is just a general hurricane intensity forecasting work that we're doing, and not just on hurricane intensity, but also on track. So improving our capabilities of predicting rapid intensification and track within the weather models. With specific to that event, we did a lot of aerial surveys after we worked with the Department of Defense and acquired two Marine Corps radars to install so that we would have radar capability there after the storm. Another thing that we're working on is with the support of FEMA is actually studying the coral system around the island, because the corals are actually very important because they act as a way to dissipate wave energy. So about 95 to 96% of the wave's energy are dissipated by the coral reefs.
Another area of reaching out to the public about environmental impact relative to Puerto Rico that can be highlighted comes from the joint NOAA-NASA SUMI-NPP satellite, which was flying then and is flying now. It has an instrument on it called VIRS that has an exquisitely sensitive day-night band. And so it can image during the night when there's only starlight or moonlight or not at all. Interestingly enough, when there is a natural disaster like in Puerto Rico and the power systems go down, areas that previously were bright because they had lights turn dark. And the SUMI-NPP images of Puerto Rico and other places have profound impacts on the public, because you can see the city was there and now this whole area is black at night because the power is out and remains out, and you can track how we are recovering from it. This is powerful connection between technology and public understanding.
Let me end by my round by staying there for a second. And I'm sure there's arguments back and forth about this. Puerto Rico deals with hurricanes every year or every couple of years, but the phrase that's used is no one saw this one coming. To that extent, to the damage that it caused. First of all, do you think that's true, or that there was enough information out there to say that this was going to be a monster of a storm? Or did it catch people by surprise? Was it human failure in not being prepared, or was it so severe that couldn't have been prepared for it?
Well, I think what we're dealing with here is a forecasting intensity problem. Obviously, before satellite imagery, no one saw these storms coming if they never made landfall. But the capability that we have now as far as ability to forecast track really trails off around day 5. So that gives you roughly 5 days or less. That also requires that the storm is initialized in the model. So if there's areas of weakness in the model, it's trying to predict when the actual storm will develop. Once it's already there, the model usually handles the track fairly well. The other hurdle is rapid intensification. There's a lot of modification that the storm does to the water underneath it, And it's very hard to derive accurate sea surface temperatures from remotely sensed satellite data beneath the clouds that are obscuring the visibility of the waters. So, you know, that's one of the areas that we're focusing some research on right now with the rapid intensification of hurricanes.
Thank you. Any comments on that?
No, NASA and NOAA are collaborating exceedingly well to get the information that's necessary to initialize the models and to understand processes such as rapid intensification. So you see that the models are improving year by year. The NOAA models are improving year by year by year.
Thank you to both. Mr. Adderholt?
As a result of climate change, what does science predict? And this would be for either or both of you. Is it increased rates of precipitation or decreased rates of precipitation?
I'll take that. In general, it's intensification of the hydrologic cycle. What does that actually mean? Higher highs and lower lows is what the models are basically predicting. That is, rainy areas are becoming rainier, and extreme precipitation events are becoming more frequent, or at least more precipitation. But the low also is getting larger. That is, droughts are becoming longer and more widespread. So it's not an all one kind or the other kind, it's an intensification of the cycle, the peak-to-peak difference.
I would just add that it's, you know, this going back to our conversation about how complex the climate system is, a lot of these processes have multiple feedback mechanisms, and they operate in a nonlinear fashion. So some of them may self-mitigate, others may scale the opposite direction.
Are we more likely to see the current climates become worse, or might drier climates become wetter, or vice versa? And that may be a little bit what Dr. Freilich was saying earlier.
In general, drier is becoming more dry and wetter is becoming more wet.
How might uncertainties with regard to physical modeling of cloud and water vapor feedback affect your ability to accurately assess long-term future of the climate? And what are some other outstanding scientific questions that inject uncertainty in your predictions?
Well, there's quite a few areas of uncertainty in the climate models. The feedbacks are obviously one. Another one is the sinks. There was a paper published last week in Nature that showed that the climate models are actually underestimating the CO2 uptake from a lot of vegetation. Additional areas are aerosols and clouds. A lot of times these aerosols act as condensation nuclei for formation of clouds. That's a complex process that's not easy to model. In addition to that, a lot of interaction with the solar output. So right now we have, with a great collaboration with NASA, the ability to observe the sun, but actually predicting what the sun will do is very complicated.
Dr. Jacobs hit the nail on the head. It's the interactions between the processes that are key, and the interactions between scales, and those are exceedingly complex.
Oh, I think we'll all agree that when interpreting data to reach conclusions that inform public policy, and us as public policy makers, it's critical to ensure that objective assessment of available data. How does your agencies encourage a diversity of research opinions on the subject of climate change to confront the issue of scientific bias?
So I'll speak for NASA.
Yeah.
Virtually all of our research programs are competitively selected, and we in the Science Mission Directorate actually are constantly looking at whether the results of that peer review process are being subtly biased or not. But the peer review process has shown itself to identify the best research, the best use of the nation's dollars in general. We make all of our measurements freely and openly available. We make all of our model code freely and openly available, and our approaches are well documented, as is the case with NOAA. So making things available in a useful way lowers the barrier of entry for anyone who wishes to either duplicate or do their own analyses. We spend in the Earth Science Division more than 10% of our budget every year on data systems, making the measurements and the information widely available.
So we have an internal peer review process as well, and when our scientists publish in journals, the journal itself has a peer review process. One of the interesting things that I've noticed with respect to the appearance of bias in high confidence versus low confidence is that there's not a motivation to publish scientific research that you have low confidence in. It probably wouldn't get past the peer review process if you didn't have high confidence in it. So what ends up happening is there's an appearance of having high confidence in this and high confidence in that because the low confidence research doesn't make it through the peer review process. Also, as Dr. Freilich said, we make all of our code as well as our data available. And one of the things that we've been working on with the various commercial cloud vendors is NOAA's big data program. And that's the commercial cloud vendors are actually hosting our data for us and developing software interactions so that anyone, whether it's a university or just someone at home, can access our data, access the code, and actually replicate a lot of what we've produced in our labs.
My time up, or we are? Okay. Sorry, thank you.
Mr. Christ.
Thank you, Mr. Chairman. Over the past year, the state of Florida, including the district I represent, was plagued by a historic outbreak of red tide. As of last October, businesses in my home of Pinellas County reported almost $1.6 million in losses due to red tide. Hotels reported a 6% drop in overnight bookings, and that's just one county. While the economic impact is glaringly obvious, and while we know that red tide is a naturally occurring organism in the Gulf of Mexico, confusion remains as to why this past year's gloom was so severe. Do you think climate change and warming oceans could be playing a role in this?
So with respect to the interactions with the water and the algae, there's a threshold. So in general, dissolved oxygen content is higher in colder water and lower in warmer water. But most of these algae bloom in a sweet spot of temperature ranges. A lot of times what ends up triggering the bloom is a precipitation event of such that creates a runoff of fertilizer. So there's nitrogen and phosphate, and a lot of times that is actually the mechanism that triggers the bloom, and then the photosynthetic algae actually remove the rest of the oxygen from the water, causing a hypoxia. One of the things that we're doing is actually through the National Water Center and the National Water Model is trying to integrate the atmospheric precipitation forecast with the water model that forecasts runoff, and that the unknown there being the amount of fertilizer that's captured in the runoff. But at least we should get to a state soon where we're doing fairly well in predicting a lot of these blooms.
What do you think is needed to help us better understand and respond to harmful algae blooms?
I would say possibly some additional measurements of chemistry in the water. Also additional stream gauges and monitoring so that we can both initialize as well as calibrate the water model. There's probably also a need to integrate a lot of the water model with flow restricted areas. So in some cases where you have dams and such that are actually, there's a human there controlling the flow rate, that's something that we would need to integrate as well.
Can you discuss, Dr. Jacobs, the opportunity that small satellites, particularly small satellite constellations currently operated by commercial companies, can play in collecting or providing data to understand climate change?
So the CubeSat industry is just now, I believe, starting to take off, and the data that they're providing, particularly with the GPS radio occultation data, is incredibly valued. It's one of the few remotely sensed observations that's an actual measurement that doesn't necessarily need to be bias corrected. So we have temperature and moisture profiles from these, as good as what we would get from cosmic data, which is a program that we run. The interest that I have is actually being able to acquire this data as a subscription service, which is, it's very convenient for us. It's very cost effective. And if there's more than one purchaser of the data, say other international Met services elsewhere, it would essentially drive down the cost of the data for us because we would be splitting the cost over other international Met centers.
If I could
please.
say a word from the NASA side.
Please.
We also see great potential in private sector small satellite constellations, and we have in place right now a pilot program with contracts in place with 3 different commercial firms who are flying small satellite constellations observing the Earth, and we're basically purchasing their data and evaluating its contributions and its value to advance our research agenda. So they're flying these for their own reasons. We're not imposing requirements on them. We're saying, since you have it, we will buy it and evaluate how useful it is, and then go in for a long-term contract if indeed it is useful. And we're finding it to be.
And we have a similar pilot program where we're acquiring and evaluating the impact of the data in our model as well.
Wonderful. Dr. Freelich, I hope I'm pronouncing that correct.
Close enough.
Thank you. In your written testimony, you stated that we are increasingly able to detect climate trends and separate them from much larger, shorter scale environmental variability we call weather. Can you elaborate on what you mean by that?
Yes. If you think of weather in a particular variable as causing rapid fluctuations, maybe the temperature goes up or goes down, or the rain happens or it doesn't happen, the climate trend is underneath that. So if you look for only a small period of time, you see weather fluctuations going up and down. But if you make continuous, long-term, intercalibrated measurements of the underlying variable, you may indeed, and we are seeing that those fluctuations are on a base which is changing over time. The satellite measurements, because they're global, because they are continuous, and because they are consistent over time, allow us to average out, if you will, the weather fluctuations and expose quantitatively the longer-term variability.
Thank you. I yield back.
Mr. Palazzo?
Thank you, Mr. Chairman. It's Dr. Freilich, right?
That is
Is that correct?
precisely correct.
Thank you.
We can go into how the different portions of our family pronounce the name
That's
differently.
right. Same with Palazzo or Palazzo.
Yes.
Depends on where you're from. I've heard both of y'all talk about hypoxia and the algae blooms, and I know Congressman Chris and I, we're Gulf states, and it's extremely important having a healthy Gulf. In Mississippi River Basin, 4th largest in the world, 32 states drain into the Mississippi River Basin. Canada, and I know we've had what's been called the Mississippi River Gulf of Mexico Hypoxia Task Force. Not sure if that's a NOAA or EPA or if there's multiple agencies that are involved in that. But the dead zone doesn't seem to be shrinking, and I know there's been a lot of flooding events, and there's the non-point source pollution coming from ag and other in urban areas. again, 32 states pouring, all this pollution point and non-point source going into the Mississippi River, and it's flowing into the Gulf of Mexico. Are we making a difference? And what can we do to maybe work towards eliminating the hypoxia task force? And I think some of the comments you've already made would probably apply to the dead zone in the Gulf of Mexico as well. But I'd just like to hear y'all's summary, if you don't mind, and start with Dr. Jacob.
We're just now on sort of the cutting edge of trying to be able to predict and understand that interaction in the research and forecast it. So it's one of those things where if we can understand the physical mechanisms and the biological mechanisms, then we can probably do a better job of quantifying future impacts and potential mitigation capability. But to do it empirically would require lengthy observation time, which is probably something we might not have.
Dr. Jacobs' answer was actually quite comprehensive.
All right. You brought up aquaculture. So between hypoxia and aquaculture, two parochial interests of mine and my home state. And I guess there is no comprehensive nationwide permitting process for aquaculture in federal waters, which I think has probably hindered America and people wanting to get into the aquaculture business, is because there's no certainty. There's the permitting process, the bureaucracies are intense, but yet, we're bringing in more imported seafood, and it's not the same quality as I believe the seafood that we find in our oceans and our seas that connect to America. But I guess, and there's a huge deficit, trade deficit with various countries. So it's not just a food safety issue, and we've had these conversations before, but it's also under I guess it's a jobs and economic. It's because these dumping of seafood is hurting our farmers, and so I guess, how would you describe the permitting process, and what can we do to improve it? And I say all this because there was a bill that Chairman Peterson and I introduced last year. It's called the Aqua Act. It's advancing the quality and understanding of American aquaculture. It's a bipartisan bill. We're going to be reintroducing it this year, and we did have a lot of input from the professionals at NOAA. And so if you could, Dr. Jacobs, I'd love to hear your thoughts on it.
So the seafood, addressing the seafood trade deficit is one of our top priorities as part of the Blue Economy Initiative. And this is something that Admiral Gallaudet has been working on extensively, and we do have a strategy and a plan that we're in the process of putting together, and I'd love the opportunity to provide that for the record.
Okay, well, fantastic, because feeding future populations and having healthy, sustainable, affordable seafood is going to be extremely important, and it not only will benefit coastal states on the East Coast, West Coast, Gulf Coast, but also our farmers in our ag states, because they'll be providing the soybean and corn food stock that will be going into the feedstock for the aquaculture. So yes, I look forward to hearing your statement.
So in terms of pronouncing names, in the Bronx, where the real Little Italy is, it's not the one in Manhattan, it's in the Belmont Avenue. We put a T in it, Palazzo.
That's correct. It's Sicilian. It's palazzo.
Not pizza, it's pizza, right?
Yeah.
Okay.
Both are good.
Ms. Kafter.
Thank you, Mr. Chairman. Your words are always instructive. Dr. Freilich, let me also again thank you for your service to our country and wish you well in the coming years. Could I ask you, could you provide to the record the 17 satellites you mentioned for Earth monitoring and their purpose? And did I get the number correct?
We have 22 satellites
22.
and major missions on orbit, and 14 more coming through FY22.
Great. Could you just provide a list
Absolutely.
of those? That would be very helpful. Dr. Jacobs, you use the term flow rate. And one of the challenges we're facing in the western basin of Lake Erie is much heavier rainfall and the inability of NASA's satellites yet to pierce the soil so we know what's happening and where the water is moving, just to give a sense of the daunting challenge to the lake. We have to hold back water flow and have slower leaching to the lake. We have no means to do that right now. We have the most tiled region in America, and every time it rains, it flows like a superhighway to Lake Erie. And half of the land in the watershed is absentee owned. So the challenge to us with these changing conditions is to be much more engineering wise. And we don't have a mechanism, and I'm urging you to think about the administration working with us, and I'm going to invite you, if both of you could come, to target the information you have and appear before the Great Lakes Task Force, which is a bipartisan group of members here in the House, to talk about the Great Lakes. And if you could call from the data that you have to give us better guidance, maybe we could do better than we are currently doing. But quite frankly, in meeting with one farmer recently, he said, "Congresswoman, I can't hold the water back. We'd have to change our whole tiling system, so we would have to work with the Department of Agriculture and invest a whole lot of money to try to figure out how to hold this water back and to probably filter it in some way that we haven't had to do in past generations. It isn't just a matter of not applying more fertilizer to the soil. There are legacy nutrients in the soil, and maybe things that happened when the soil was first created that are flowing into the lake. And we can't save the lake without re-engineering the watershed, in my opinion. So data you could provide us specific to that region could be very helpful. I don't know if you've seen a film, I wish we'd made it in this country, a documentary called Planet Ocean, done by Jan Artus Bertrand and Michael Pityat from Australia. I guess the ocean surrounds them, so they think about it more. I just love that film. And as I looked, Doctor, at what you put up there from NASA, I thought, okay, I'm going to push you a little bit further. Take a look at their film and see what each of you might have in your treasure chest, in your departments and agencies. And what could we tell the American people about the United States of America in the way that the Aussies did in that particular documentary? I think it could be very important to public education and, frankly, to education of members here. So I would suggest that. Finally, I just wanted to ask you, in the time remaining for me, could you discuss, based on your work, trends you see in desertification in our country? Talk about the Great Lakes, where 80% of the fresh surface water of the United States exists, and also coastal impacts. Congressman Christ is here with us today from Florida. Do you have any comments you want to make to us about our arid West, about our coastal regions, or about the Great Lakes that are summary remarks, thoughts that you've had as you look at the data sets, and that would give us guidance as members? It's a hard question, but...
It is. By the way, as an oceanographer, I resonate with your sentiments about the ocean, absolutely. So thank you very much.
I didn't know you were an oceanographer. Well, watch the film and tell me if you think it's as good as I think it is.
It is. I've
Okay,
seen it.
you've seen it. Okay.
So my answer would go back to the discussion that we had previously with Mr. Adderholt in terms of intensification of the hydrologic cycle. Although we have the ability technologically and infrastructurally in this country to mitigate some of that, there is an increasing trend towards dry areas, and especially in the West, not in your area, the precipitation patterns leading to water stored in snowpack, which is where most of the water comes from for agriculture in the West, has been changing. So the drier dries and the change in precipitation amounts have evidenced themselves generally in terms of increased drawdown of aquifers.
All right, knowing that, and looking 50 years out, over half our fruits and vegetables now come from one state. Do you see that changing in the future because of the availability of water? Don't know. Neither.
Not my expertise, I'm sorry.
We'll try a couple of more questions, and then we'll call it a morning. And we thank you for your testimony today. Some communities are already making massive investments to protect themselves from climate impacts. New York City, for instance, has a massive plan to build barriers to protect itself from another superstorm Sandy. These types of investments are enormous and should be made with the best possible information about climate change and the risks that it poses. For both of you, what are the most important investments to make in climate science and research so that we can reduce the uncertainty with regard to these risks?
I would say I would categorize the investments in three areas. The first one is observations. This is critical both for in situ observations, for initializing models, as well as validating predictions. And then the modeling, both weather modeling and climate modeling. We're slowly closing the gap between weather models and climate models. And we're actually learning from the development of both sides to benefit the other. The last one is investment in compute resources, both HPC and cloud-based compute resources, because in order to do these computations, it requires a tremendous amount of computing capability.
Spot on. Measurements, models, and communications of the results.
I'm hoping, Ms. Adderhold, that every panel we have from now on agrees with each other as much as...
NASA and NOAA have been working together extraordinarily profitably for an exceedingly long time.
I understand. Related to this, what do each of you consider to be the greatest unknowns in climate modeling today? And what are your agencies doing to address these?
In no particular order, I think the real challenges in climate modeling are understanding the feedbacks and the interactions, the various CO2 sinks, the cloud aerosols, and getting accurate initialization from those. And then understanding the natural patterns, because in order to isolate any sort of anthropogenic patterns, we need to understand the natural signals and be able to subtract those off.
Yeah, Dr. Jacobs, again, was spot on. I want to focus a bit on the natural extended sources and sinks of carbon dioxide, not the point sources. On average, about half of the anthropogenic CO2 that we put into the atmosphere stays in the atmosphere. The other half goes to the land and the ocean in ways that we don't entirely understand. And some years, almost all of the CO2 that we put into the atmosphere globally stays in the atmosphere. And in some years, almost none of it stays in the atmosphere for more than a few months. Understanding the sources and the sinks in the oceans and the boreal forest and how they interact and how they will change in a changing environment is critical for understanding what the atmospheric composition is going to be in the future, and therefore the radiation balance.
Thank you. Is that all?
Let me just follow up on that. Dr. Jacobs, you mentioned that substantial progress has been made over the last several decades in earth science, in earth system science observation modeling, but that the mission remains incomplete and many questions still remain unanswered. Can you go a little further and explain, what you would say, what the questions remain unanswered, and what additional advancements can be made to address these outstanding questions?
Well, so I guess I would bin this into two categories. One would be, what are the assumptions in the representative concentration pathways? So there's 4 different pathways. There's a 2.6, 4.5, 6, and 8.5. Ranging from very minor emissions increases to very extreme emission increases. Now, there's assumptions based on those. 8.5 is associated with a higher population growth and less technology innovation, and 4.5 is lower population growth and higher technological innovations. This is beyond the scope of NOAA's mission to evaluate the feasibility of these, but I do think as policymakers, the baseline assumptions of the RCP scenarios should be analyzed. And then when we, NOAA, actually use these various scenarios to then project what we think the climate and weather is going to do based on those scenarios. And I'm confident that we're making a lot of progress in our understanding of the science when we initialize with those scenarios what the outcomes will be. But a lot of the question, I think, is really on what are the scenarios going to be.
Oh, will any of these advancements be able to slow global warming in the short term?
Really, as part of NOAA's mission, we're just observing the trends in the atmosphere and trying to predict them. It's really up to the policymakers to decide if they want to implement something one way or the other that may or may not make a difference.
Dr. Freilich, you want to add anything?
Same. NASA makes the measurements, does the analysis, and informs you. Then once you make a policy decision, together we monitor the Earth system to see whether the impact is what you had expected.
All right, I'll yield back.
Wanted to follow up on my prior request. Would it be achievable for both of you to meet with the Great Lakes Task Force and reduce your data granularly to the Great Lakes region, or is your data more diffuse?
I will speak personally for myself. I'm sure that NASA would be happy to do that. In 3 days, I will be retired.
Only 3 days. Dr. Jacobs?
Absolutely.
I didn't know at what level your data existed. That's why I was asking the question.
Well, it depends on the various data sources. Some of it's extremely high resolution, both in space and time, and some of it's fairly sparse. But we do make that accessible and available to the public, as well as the software that we use to process it. And that's all. You can go online and get that now.
Right, but it would be nice to hear how you're collaboratively working in different regions of the country and reduce it in ways that we can act on then. That would be very helpful to us. I wanted to ask a question about, 2 questions and then I'll be finished. One is it possible that what we are experiencing is being heavily influenced by changes in the Earth's orbit or its positioning? That in fact, there's more going on than just human behavior and its influence, but there's something else going on as well in space. And then secondly, what do each of you have to present today or in the future to the record about energy and the use of energy on Earth and the Earth's environment?
So to address your first question, there are undoubtedly changes that are happening on very long time scales, because we know that the climate has changed on long time scales back throughout the history of the Earth. However, what we are seeing today are environmental changes that are happening far more rapidly than could be accounted for by things like orbital dynamics of the Earth, and therefore must be the result of other factors. But both things are happening, long-term changes and short-term changes. The short-term changes right now are happening intensely and, of course, rapidly.
I think one of the most effective photos NASA put out was the one showing the ozone layer healing because of decisions we made as intelligent beings. Obviously, with some of the other challenges we face, we have some work to do. But I thought that was very effective, and it showed working together we can make progress. Do you wish to comment, Dr. Jacobs?
That was a great answer. I have nothing to add.
Okay, what about energy and the environment? What about satellite imaging of changes in the use of energy with population growth? Do you have any time series data that would help us see how we collectively, as humanity, impact the environment because of our use of energy?
I would say that the issue is not necessarily the use of energy, but how it is that we generate that energy. If we generate that energy by burning fossil carbon and adding that to the system, that has one kind of environmental impact. If we generate that energy in other ways, then the environmental impact of the same amount of energy will be much different. So it's not the energy itself, it's how we got it.
I would just add to that NOAA does provide high-resolution wind forecast as well as cloud forecast and such that can be used by renewable wind energy and solar farms, but we don't actually, beyond the scope of providing that atmospheric information, that's where our jurisdiction stops.
All right, thank you both very much. Thank you, Mr. Chairman.
Thank you, and thank you to our ranking member for today. This has been a very interesting hearing, and one that continues to be an issue of much contention. As I said at the beginning of the hearing, either in making a bad attempt at humor or being profoundly sarcastic, if we can't agree on what to call it, then maybe we can just agree that something's going on. And you folks are doing a great job at trying to find out what is going on and telling us, you know, what may be causing it or not causing it. But it would seem to me that there is a large amount of this, if not all of it, caused by we ourselves who inhabit this planet. And it's the planet we have. It's the only planet we know that we can be on right now. NASA hasn't shown us that we can be on another planet yet, although I think that's coming soon. But one of the reasons that I love this committee, and one of the reasons that I wanted very much to get an opportunity to chair this committee, to be ranking member, as I was in the past, is because of these two agencies that are in front of us now. You do such important work and such important work for the American people and to help us along to understand where we are. And just for the record, as far as NOAA, I've always said NOAA is one of those agencies that really has to go out of its way to harm somebody, because it's always trying to help somebody. And to NASA, I say something very district constituency related. You've never seen a crowd react to a congressman bringing someone to a school as when you bring an astronaut. I mean, that is absolutely incredible. And we have to do more of that, continue to tie in the work of both agencies to the schools, because this excitement. I saw a group of kids just looking at weather maps and looking at NASA at maps taken on a trip to space, and they were glued to that screen. You go and the teacher said, "Okay, you in the back, relax," and it didn't happen. They were glued to it. So we should work on that. So thank you so much. Thank you for helping us through our first hearing. Wish I could say this is the last hearing of the season, but it's only the first. Thank you so much. And hearing is adjourned. Wasn't too painful, right? Thank you, my friend.